Good morning, children. In the last class, what we have discussed, we discussed about the acids, bases, and salts. What is a neutralization reaction? What is neutralization reaction? When any acid reacts with a base, it forms salt and water. Such reactions are known as a neutralization reaction. And any metal, when reacts with an acid, it liberates the hydrogen gas, a colorless gas. And how you will identify that colorless gas as hydrogen? When it is put up the burning splinter or a mastic with a pop sound, then the colorless gas is identified as a hydrogen. Now you see, children, and how acids reacts with carbonates, metal carbonates. With the carbonates, it forms salt, water and carbonate, water and carbon dioxide, and with the metal bicarbonates also it forms salt, water and carbon dioxide. The carbon dioxide which is formed, it reacts with a quicklime and it forms a calcium carbonate which gives reacts with atmospheric carbon dioxide and gives the white finish on the walls. The whitewash which we do, that is calcium carbonate only. Next, we discussed about the pH. pH is help us to find the strength of the acids and bases. Strong acid, strong base, weak acid, weak base. If a value lies between 1 to 5, then it is said to be a strong acid. Less than that, it is said to be a weak acid. And 8, 9, 10, it is said to be a strong base. And more than that, it is a weak base. 7 is a neutralization. 7 is a neutralization. See, children, here pH, how it is used in digestive system, how it is used in tooth decay, how it is used in finding the nature of a soil, and pH in aquatic animals. If a rainwater acid rains less than 5.6 acidity, then that rain is said to be acid rains. When that acid rain enters into the lakes, rivers, it affects the aquatic animals and aquatic life. Even tooth decay also. So whatever the food we are eating, if it is leftover food in that mouth, what happens? The acids arose and it corrodes with the teeth and it affects our tooth enamel made up of a calcium phosphate. So to avoid that, we should brush with a base. Okay, that is toothpaste is nothing but a basic in nature. Even hydrochloric acid is produced in our stomach, but too much of production of that hydrochloric acid creates a pain and irritation in our stomach. To avoid that, we need to take an antacid tablet, that is a mild base, that is a magnesium hydroxide. And pH of a soil, how you will find the pH of a soil? Take a soil in a test tube, add a little bit water and shake it. As it is homogeneous, the color of the water changes but does not mix. Filter it and dip that in a blue litmus and red litmus. If it is an acidic soil, basic fertilizer is added. Basic soil, acidic fertilizer is added to neutralize. Even self-defense from the animals, birds and animals also. How you will self-defense? Honeybee stings, then ants will, when it bite and sits on our body, they release a acid, tartaric acid. So we will get a pain and irritation. To get rid of that pain, that pot is rubbed with a baking soda or a nettle plant which is a basic in nature. Dog plant, not nettle plant, dog plant. You have to rub that pot with that leaf. So this is some remedy for self-defense from the animals. Okay. What are the salts? We got sodium chloride, bleaching powder, baking soda, sodium carbonate, gypsum, plaster of Paris, crystallization of a copper sulfate. All these topics in the last class I explained you. Go through that, children. Most important lesson, acids, bases and salts, and easy also. Okay. Now let us start today's revision. Refraction of a light at a curved surface. Refraction of a light at a curved surface. Activity 1. What he asked that if you fill any glass with a lemon water and just drop a lemon. If you observe the lemon from the outside, it looks bulge. It is not a exact image of the lemon, but it looks in water. And next, these are the rays when they passes through the curved surface. So any ray passing through the center of a curvature, that is an undeviated ray. any ray parallel to the principal axis when passes from rarer medium to denser medium. What you are observing, see the figure 4a, ray is entering from rarer medium to the denser medium. So refracted ray bends towards the normal. Refracted ray bends towards the normal. Now you see the 4b. Here refracted ray bends away from the normal. When a light ray travels from denser medium to the rarer medium, in the case of a convex surface, concave surface, it is bending towards the normal. In the case of a convex surface, it is bending away from the normal. Now any ray striking the mirror, normally incident on that, and it is moving away from the normal, and here it is towards the normal. These four situations are important. And the image formation and derivation of a curved surface formula. Here this formula I already informed you. Formulas derivation is not important for your essay 1 as well as essay 2 also, but formula is important. With this formula you are going to derive, going to solve some problems. That is n2 by v minus n1 by u is equals to n2 minus n1 by r. Next, some related to that problems are given, already it is solved. So just practice once that problems. Lenses. What is a lens? Lens is a formed by transparent material bounded by the surface. One of the surface should be curved surface in that. And we have the 6 types of lenses. First 3 are converging lenses and last 3 are diverging lenses. What are that? Biconvex, plano-convex, concavo-convex, biconcave, plano-concave, convexo-concave. So all these are the some types of lenses. So any ray passing through that lens, how will be the ray after reflection? So here you can see the symbol of that lens. Arrow mark, it shows a convex lens. Inverted arrow mark shows the concave lens. Convex lens and concave lens. Now children, behavior of certain light ray when they are incident on a lens. Situation 1, ray passing along a principal axis. See the 9a, 9b. 9a is convex lens, 9b is concave lens. How the ray is passing through principal axis. On the axis itself ray is passing. On reflection or when it passes through the lens, it is undeviated ray. Undeviated ray. Now here you can see 10a and 10b. They are passing through optic center. Center of the lens is said to be an optic center. 10a is convex lens, 10b is concave lens. So any ray passing through optic center, it is undeviated ray. First situation, any ray passing through principal axis, it is undeviated ray in the case of convex lens and a concave. And any ray passing through the optic center, it is also undeviated ray. Third situation 3, rays traveling parallel to the principal axis. Rays traveling parallel to the principal axis. Any ray passing through the principal axis converge on its focus. Converge the focus or appear to be diverse from the focus. He is asking us to see the 8a and 8c and 8d. Passing through focus. Any ray passing through focus, let us obey the principle of least distance. Hence the ray passing through focus will take a path parallel to the principal axis after refraction. After the refraction, how the rays are passing through focus. So when after refraction, when it passes through the lens, it undergoes refraction, suffers refraction and parallel to the principal axis. Parallel to the principal axis. Next 12a, 12b, you can see that the case of concave and convex lens, any ray making certain angle with respect to the lens, on refraction it converges at a point. That point is said to be a focal plane. What is meant by focal plane? The plane which is perpendicular to the principal axis is said to be a focal plane. So these are the some ray diagrams. Any ray passing through optic center, how will be the ray after refraction? It will be parallel to, it is undeviated ray. Any ray passing through the principal axis, it is also undeviated ray. Any ray passing through the focus, it is parallel to principal axis. Any ray passing through parallel to principal axis converge at a focus. And any ray making certain angle with respect to the lens on refraction, it converges at a point, and that point is perpendicular to the principal axis, is said to be a focal plane. Rules to draw a ray diagram. First, select a point of the object on the principal axis. Draw two rays to get the image from the four situations. Extend both the rays and intersect a point. That point will give the position of the image. And draw a normal from that point to the principal axis, that will decide the size of the image. So these are the four some sign conventions you have to remember. First, what is that sign convention? Always object should be placed on the principal axis. Select a position of the object on the principal axis, and from that draw any two rays from the four situations which strikes a mirror and reflect and converge at a point, and the point of the converging will give the position of the image. And draw a normal from that intersecting point to the principal axis, that will decide the size of the image. Okay, next, object at infinity. What do you mean by an object at infinity? See, this is the first object at infinity. What do you mean by object at infinity? What type of rays fall on the principal lens? You know that rays falling on the lens from object infinity are parallel to the principal axis. You know that sun is at infinity distance, and if rays are falling on the lens, how will be the parallel to the principal axis? This is the first situation. Second, they converge to a focal point, so the size of the image formed at focal point. Point sized image is formed at focal point. Point size means small sized image. Object behind the center of curvature on the principal axis. You can see the object where is beyond the center of curvature. Beyond the center of curvature. So how many rays should be considered to get the image? Two rays. What are they, ma? First ray is parallel and second is passing through optic center. Both are converged at a point, and the intersecting point between the 2 points, that is F and C, is said to be position of the image. So any ray, when object is placed beyond C, both will intersect at a point in between F and C, and image will be formed in between F and C. Object placed at the center of curvature. When object is placed at the center of curvature, where you will get the image? On same center of curvature, and which is a real, inverted, and the same size. Object placed between center of curvature and focal point. When object is placed between C and F, image will get beyond C, and how will be the image? Enlarged image. Object located at the focal point. When object is placed on a local point, we will get the image at infinity. As we cannot see the image, we cannot discuss the size and nature of the image. So all these situations, 5 situations and one more, these are important for your ray diagrams and long answer also. Object placed between focal point and optic center. Where is the object? You see in between F and P. Where you will get the image? Same side you will get the image, and it is an enlarged image. As it is not caught on a screen, it can be seen directly in a mirror. It is said to be a virtual image. So these 6 situations help us to get the different types of images, nature of image, and position of the object also. Okay, clear children? Most important ray diagrams. When object is placed between P and F, where you will get the image? Beyond, inside the mirror. On F, infinity, and between F and C, beyond C. Beyond C, between F and C, and on C, image also on C, and the same size. So these are the some 6 situations where object positions are changed. Due to change in the object position, image positions also changes. Okay, now let us talk about the completing the ray diagrams. Incomplete ray diagrams are given. You need to complete. Next, lab activity. Observing the types of images and measuring the object distance and image distance from the lens. So different types of the images. How will get the different types of images? Measuring the object distance. Changing the object distance. So measure the distance of the image from the V stand of a lens and also measure the distance between the candle and the stand of a lens. Already we discussed that is placing on a V stand and finding the different types of images. So by using that, object distance is U, image distance is V and focal point is F. Can you find the relation between U, V and F? Yes, we have one relation, that is lens formula. This is a lens formula. 1 by F is equals to 1 by V minus 1 by U. Mirror formula, 1 by F is equals to 1 by V plus 1 by U. There it is plus sign. Here for lens formula we have minus sign, that is 1 by F is equals to 1 by V minus 1 by U. Clear children? Mirror formula we discussed in our first lesson. I already explained you. Derivations are not important. With that formula you have to solve the problems. Here lens formula also derivation is not important, but with this you can solve the problems. That is 1 by V minus 1 by U is equals to 1 by F. 1 by F. Okay. Now magnification. What is meant by magnification? Hi by Ho is equals to minus V by U. Hi by Ho is equals to minus V by U. That is a magnification. Height of the image by height of the object is equals to image distance by object distance. Okay. Clear? Based on that, the simple formulas are given. You have to solve. Already solve problems. Just you check them out. Next, activity 2. What is that activity? Take the same lens that was used in activity 2. Note the average focal length of that lens and that was calculated in the activity. Take a cylindrical vessel such as a glass tumbler. Its height must be much greater than the focal length of the lens, and what we have to do, it should be filled with the water. The level of the water is less than the focal length. Now with the help of a lens holder, just fix the lens in that and dip in a water. In the bottom of that beaker, you arrange one black stone. Now just lift up the lens with the help of a lens holder such that you cannot see the image of the stone. So what you are observing, as length is increasing, distance is increasing, the image we are not able to see. So from this we can say that focal length depends upon the nature of the material, nature of the medium or a material, medium that is. So from the water medium to the air medium, as we are lifting up, due to change in the medium and focal length also changes, that's why we are not able to see the image. So from the simple activity, we are going to conclude that focal length depends upon the surrounding mediums. Clear? Next, lens maker formula, that is 1 by V minus 1 by U is equals to n minus 1, 1 by R1 minus 1 by R2. Modified form of this is 1 by F is equals to n minus 1, 1 by R1 minus 1 by R2. Here also remember the formula, no need of derivation. Okay. Next comes to, and based on that formula we have one problem, that is 1 by F equals to n minus 1, 1 by R1 minus 1 by R2. What is n? Refractive index. What is R1 and R2? That is refractive index of first lens and second lens. F is a focal length. So by using this you can find the, what are the keywords? Lens. What is meant by lens? A transparent object is bonded together. One of the surface should be co-surface. Focal length, the distance between optic center to the focus point is said to be a focal length. And when all the parallels strike the lens and converge at a point is said to be a focus. Optic center, center of the lens is said to be optic center. Principal axis, the line which joins P and C is said to be principal axis. And radius of curvature, distance between P and C is said to be radius of curvature. Center of curvature, where all the normals will converge, or a point from where we will draw the normals, such point is said to be center of curvature on principal axis. Focal plane, any plane which is perpendicular to the principal axis is said to be a focal plane. So these are the topics we discussed here, and the lens depends upon the surrounding medium is most important answer. And next, with the help of formula, that is one lens maker formula, that is 1 by F is equals to n minus 1, into 1 by r1 minus 1 by r2. With that formulas also we are going to solve the problem. Most important, 6 ray diagrams, different positions of the object also important, and 4 situations. What are the 4 situations? Any ray passing through principal axis, undeviated ray through lens. Any ray passing through the lens from the optic center, it is also undeviated. Any ray passing through focus on refraction, it parallel to the principal axis. Any ray making certain angle with the lens, it converges at a point which is perpendicular to the principal axis, is said to be a focal plane. From this 4, you need to consider any 2 rays to get a image. So what are the rules to be followed to get the image? First, select the position of the object on a principal axis. First rule. Second, draw any 2 rays from the first situation to get the image, and the intersecting point of that 2 rays on refraction is said to be a position of the image. Drawing a normal from that intersecting point to the principal axis will decide the size of the image. Clear? So 4th lesson, ray diagrams are important, and the focal length depends upon the surrounding medium, that is also important. Problems on a lens formula, lens maker formula are important. 6 situations where different objects, positions of the object, and different image positions of the image. Clear, children? And let me remind those who did not completed the work of activity 1, project 1, activities and project summer, please try to complete and complete your class work also. So if we complete, then only we can give the internal marks summer. If not, we'll put 0. So it depends upon you, that is getting 15 marks as a part of internal is it in your hand, and 5 marks depending upon the test. If you prepare well, writing part 15 marks you will get, project 5 marks, activity 5 marks, and classwork written skill 5 marks. So slip test, if you lose half mark, 1 mark also doesn't matter. So try to complete that writing part at home. Okay, children? And read whatever the lessons we are revising daily, 3 subjects you will get. On the particular day, if you complete that revision, it becomes easy for you to score good marks in essay 1. Okay? Thank you, children. All the best.